You know, at first glance, when you look at the surface of Mars, it just looks uninhabitable, especially when you consider that the atmosphere is 1% as thick as ours and comprised of carbon dioxide, which is poisonous to human life after all, and it just seems that Jeff Bezos and Bill Nye and their ilk might be right. Living here would be so difficult as to make it impractical, and would be a living hell for anybody who attempted it. I mean, Jeff recently suggested that living on top of Mount Everest would be a paradise compared to living on Mars. And if you look at some of the basic scientific data, he kinda seems right, doesn't he? Well, I'm here to tell you that he isn't. Mars was actually a very habitable place for some time in its ancient past. There's all sorts of surface indications to suggest this. Mars was once covered in water, and that water did not all bleed off into space. Trillions upon trillions of tons of water ice remain just below the surface, all over the planet, and that water ice is all we need in order to be able to survive long term. And there are some other very unfair and frankly stupid comparisons to be made between Mount Everest and Mars. Everest is a beautiful but horrifying place with extremely powerful winds, as you can see here, that would blow away any habitat you tried to put on top of it. Plus, it's home to killer avalanches that have ended the lives of so many people who have attempted to scale it, and its nearby companion of K2 has been even more deadly, and Mars has none of these characteristics. On the other hand, Mars has many indications, as you can see here in this false color image, of river channels and oceans having existed in its past. Now granted, this water is gone, but it isn't gone into space. It's beneath the surface, ready for us to use. Mars is also a place of wonders, unparalleled in the solar system for us to explore, a place that would just be full of adventure, but it would be extremely difficult as well. Would it be worth this extreme level of difficulty? Well, we're gonna find all of that out in just a few minutes. Good evening, and welcome to another episode of The Angry Astronaut. So, as you probably have noticed from the couple of shorts that I've done in my live stream, I am finally home. I have not slept extremely well for the last several days. I'm not sure if it was all the traveling or just getting exhausted, maybe a little heat exhaustion. I don't know. South Carolina is hot, but nothing like South Texas hot, let me tell you. But anyway, let's get back to Jeff. Jeff. Do you ever get tired of being wrong? I mean, I don't understand how you can be the wealthiest person on the planet, well, depending on where the stock is, and be wrong so often. And this is his greatest offense, in my opinion. I mean, we're talking about a guy that is supposedly concerned about the future of the human race, who's investing heavily in fighting global warming, climate change, that sort of thing, presumably for the future of mankind. And yet, he can't see past the fact that no matter what we do, no matter what action we take on this planet, if we stay confined to the cradle where we were born here on this one planet, our fate is completely sealed. Someday, sooner or later, our civilization will suffer a catastrophe from which we will not recover, and we will go extinct. And that can happen sooner rather than later. Hell, with nuclear conflict, it could happen tomorrow. And given the thousands of nuclear weapons that Russia and the United States still possess to this day, to say nothing of the arsenals of other countries, it would be truly devastating to the point of annihilating our entire species if we were unprepared for it, which of course we are. So, and that's just one of a variety of things that theoretically could happen. Becoming a multiplanetary species is the only solution to that problem. So, but does he have a point about Mars? Would Mars be that horrific? Now, of course, comparing it to the upper levels of, to the summit of Everest is a comparison in terms of atmosphere and temperature. The atmosphere at Everest, at the summit of Everest is extremely thin. You require, oxygen, at least most humans do require additional oxygen in order to survive. It's incredibly cold, even during the summer. It's a very hostile place that has taken quite a few lives, and so has K2, as I said during the introduction. However, is that a fair comparison just because of the atmosphere and the temperature? Well, no, it is not. There are so many things about Mars that make it nothing like Everest. And even though Mars is a formidable place and a place that it would be difficult to survive on, it would not be impossible, nor would it be miserable. Now, granted, the vast majority of people on this planet would not enjoy the experience. But if we're talking about 1 million people, that's a tiny percentage of the world's population, far less than 0.1%. So we're not talking about a lot of people here if you're talking about the whole population of the planet. And you wouldn't even need 1 million people there in order to sustain the species. You'd only need a few hundred, really. But still, living on Mars would not be a living hell. And I am going to prove that to you right now. Now, perhaps shelter isn't the first thing on everyone's list when it comes to surviving on another planet, but it's on mine because if you don't have adequate shelter against the Martian environment, you're dead. So this is the Marsha, something that I have talked about many times, an interesting design that involves essentially a vertical cylinder, which they discovered was the most efficient use of space and building materials. And since building materials come at a premium when you're traveling tens of millions of kilometers from Earth, that is a very, very big consideration. But one of the most fantastic things about the Marsha is very little in the way of building materials needs to be transported to Mars. The majority of it is made 3D printed from concrete gathered from the surface of the planet. Now, we always talk about living in domes, but look at all the wasted space and inefficiency in a dome design compared to what AI SpaceFactory has come up with when it comes to the Marsha. Just so much more efficient in its use of space, plus, as you can see, natural division between the types of work that's being done on different levels of the facility. They've also found that this shape is the most easily constructed by 3D printing, which is the whole idea, using the Martian regolith and basaltic fiber, which is incredibly strong and incredibly radiation resistant, in combination with something called renewable bioplastic or polylactic acid, also called PLA, processed from plants. Now, obviously, there's no plants on Mars, but still, you can use waste from all of the greenhouses to create that. You just saw the mobile mounts at the bottom that this thing moves on. The extreme nature of the Martian climate requires that this structure expand and contract with the temperatures. Otherwise, it's not going to hold up. A brilliant design that allows the structure to be stable and yet adapt to the Martian climate. And look at this amazing skylight filled with water for radiation protection. The water actually circulates through all the windows for maximum radiation defense and yet allows natural light into the structure. And you can see the pattern of recirculated water and recirculated air, a self-contained unit isolated from the hostile environment outside, very comfortable, beautiful from an architectural standpoint, and therefore comfortable to live in. Something like this would be so impractical on Everest. It would be so hard to get the materials up there. It would get buried in snow and possibly destroyed by the extremely powerful winds that exist up there. Mars does not have these kinds of winds at all, nor does it have snow. And again, look at the interior, designed for comfort and beauty, and just a place that you can relax while you're doing your work and living in such a hostile environment. This doesn't suggest that you would live inside all the time, but when you were inside, you would feel comfortable. You would feel like you're in a home rather than in some sort of scientific facility or in some kind of bunker or in a lava tube hiding from radiation. Unnecessary with this structure because of how it's constructed. All of this 3D printed basaltic fiber combined with the PLA provides tremendous protection from radiation. And as you can see now, it is all constructed by robot, section by section, using some components that are brought from Earth, but the vast majority of it is being constructed using materials from the Martian surface, primarily basaltic fiber. And since Mars has had such an active volcanic past, basaltic fiber would be extremely plentiful all over the planet. Not so much on Mount Everest. And by the way, although this is obviously a computer animation, this is something that has been tested in practice in a scaled down version before it won a contest through NASA. The conditions of this contest were pretty straightforward. First of all, you had to use materials from simulated Martian regolith in order to produce your structure within a certain frame of time, and it had to be completely automated, and it also had to be resilient. And as you can see here, all of this was done by robot, and although we can't say for 100% certain what Martian regolith is like, we can make some pretty damn good guesses. And here we go, the robot not only building the structure, but inserting the pre-built windows, and also it is a two-shell structure. In other words, it has this exterior portion that's made out of basaltic fiber concrete, and then it has an interior sleeve as well, manufactured again from materials that can be either made on Mars or will be found on Mars once we have a presence there, because obviously we're going to have large greenhouses, and the types of materials required for this particular sleeve that's going to be used inside the Marsha is something that can be easily manufactured from what we're going to be bringing and what we're going to be growing there. The Marsha is a brilliant design, which is why it was one of the winning designs in this contest. And since I'm an incurable geek, let's have a look at the interior structure of this design, not just how it's going to be built, because the inside is just as brilliant as the outside. So here's the details of the internal construction. All of the windows, all of the doors, at first anyway, need to be manufactured on Earth, but something like the Starship could easily handle quite a few of these actually, enough for several Marshes. The rest of it, as I've said, is constructed out of basaltic fiber found on the Martian surface by 3D printers. And as far as the windows are concerned, there's one of them on every level, providing a panoramic view and natural lighting, making just living in the interior of this thing a lot more pleasant. 4 levels of polycarbonate insulation around every window and 4 window panes, providing the maximum amount of insulation against the Martian environment, and as I said, water flowing through it at least during the daytime to provide radiation protection. But as the Curiosity has discovered with its radiation readings, the closer you are to a cliff, the more radiation drops off, precipitously actually. So a window located here, anybody on the inside of that window would not actually get much radiation at all, even if there was no water present. So, and especially during the night, there's no need for water because the sun is down and the presence of cosmic rays and radiation is far lower. And as far as the skylight is concerned, this is just genius, filling the structure with so much natural light, and natural light contributes so much to people's psychiatric well-being. Does this look like living at the top of Everest to you? Not to me either. So on level 1, you have access to the surface, an airlock that gives you direct access to the rover. You also have ingress-egress points to the spacesuits, eliminating the danger of bringing Martian dust inside, which is loaded with perchlorates and therefore is dangerous. You also have a wet lab and EVA prep. On the second level, you have a dry lab and a kitchen and 2 windows, again providing both natural light and a beautiful view. On the third level, you have sleep pods, sanitation pods, which everybody needs, of course. You also have a garden and 2 more windows, and then finally at the top, recreation and exercise, another window, and of course that magnificent skylight. Once again, does this look like some lousy tent at base camp on Everest? No. But what about what we're gonna eat? I mean, look at what the astronauts have to eat. Granted, it's not that bad and it's gotten better over the years, but it's kind of like eating baby food all the time. Well, that's because of microgravity, which doesn't exist on Mars. It's 1/3 gravity. This pyramid design is a combination aquaponics system and power grid. It combines the solar energy of a field of solar panels and uses that concentrated energy at the summit of the pyramid to produce enormous amounts of energy, plus a lot of natural light for aquaponics. And aquaponics does not require soil, it simply requires fish and water. Obviously, there's a lot of water on Mars, but what about the fish? Well, tilapia eggs only hatch at a certain temperature and remain in storage otherwise, and as far as we know, this works in microgravity. So you keep the eggs on ice, essentially, in a preserved state on the spacecraft on the way to Mars, and then allow them to hatch once you arrive. The fish provide ammonia and waste, which is filtered up into the plants, which converts that into nitrites and nitrates, which is devoured by the plants, and it cleans the water completely and then is pumped back into the fish tank. And the waste from the plant life can actually supply the fish as well. It is a completely self-contained, efficient system that produces amazing produce of all kinds, plus raspberries, blueberries, just about anything you can think of, except if things that grow on giant trees, of course, that would come a lot later. But you get fish, too, out of the deal. There are many other ways to grow things on Mars. This is my favorite. Oh, and by the way, this is produce grown by aquaponics, and this system can produce 100,000 kilograms worth of produce per year, or enough food for 100 people for a whole year out of 1 damn acre. Can you see why I like this system? But what about what we wear? Well, this photo is not from some sci-fi movie of some heroine. This is actually a spacesuit that would work on Mars. Now, a lot of you have probably seen this before on my other videos, but this is Professor Dava Newman of MIT, and this is her biosuit, a suit that uses a principle called reverse mechanical pressure in order to provide the necessary pressure and insulation to protect a human being from the hostile Martian environment. And it's been tested in vacuum, but not with a human being inside yet. It still requires a little bit more research, a little bit more investment from NASA, which of course they haven't given to MIT because they're idiots. Oh, okay, all right, I shouldn't have said that. But still, look at this. Look how easy it would be to maneuver around in this compared to these giant bulky spacesuits. And also, they're a lot safer too. I mean, you have a lot more flexibility, ease of movement, and if you get a cut in your spacesuit, the reverse mechanical pressure system actually seals the cut off and you can patch it at your leisure. And what about your oxygen supply? Well, you could carry it yourself, or as NASA is just about to approve, you can have a robot carry it for you, like the Boston Dynamics Zeus. So moving around on Mars could actually be a hell of a lot easier than astronauts have to contend with these days. And then the final question, what do we do? Well, that's pretty damn obvious. How about watch a blue sunset, courtesy of the carbon dioxide atmosphere that we find so formidable? It can also be beautiful, or just explore this unique planet, such as the Hydraeus Chaos, and I think I'm pronouncing that right, this region of the Valles Marineris that is a labyrinth of canyons, narrow canyons with canyon walls that go up thousands of meters. There are some regions of the Valles Marineris that have canyon walls almost as tall as Everest itself. Nothing in the solar system can compare. And here's a bunch of other examples for you. You probably want to fly over the ice caps, but the Marth Valles is a fascinating place, and this isn't false color. This is what it really looks like. Sedimentary deposits left over from ancient colossal river valleys, and both ice caps, again, being fascinating perhaps to fly over in a balloon of some kind. And then you have Becquerel Crater. That central mound is a kilometer high, made of sulfates polished by the wind. Casse Valles, not the Valles Marineris, but still hundreds of kilometers long and up to 3 kilometers deep. And then Rabe Crater, that is a fascinating place with dark dunes hundreds of meters tall. And then the Hebes Chasma, which is part of the Valles Marineris. All of these magnificent places to explore, unique and different, and nothing like we have on Earth. A planet full of wonders waiting for us to explore it. Olympus Mons just being one example of the massive volcanoes on this planet. The little cliffs you're looking at right there, the plateau that it sits on, that's as high as Mount Everest, to say nothing of the volcano. This planet is magnificent, and I think that the first cities should actually be inside the Valles Marineris for reasons that I explain in another video that I have linked in the description. Nevertheless, just look at all of the wonders that this planet has to offer and ask yourself, would this really be like living at the top of Everest for the rest of your life, or would it be the greatest adventure of your life? And let me say one more thing about radiation. The radiation levels on the surface of Mars are about the equivalent of the radiation on the ISS. You could be unprotected from radiation for years on the surface of Mars without significant risk of cancer. Granted, you would have to stay in your habitat most of the time, but you could spend so many years of your life exploring this beautiful planet. Why wouldn't you want to? Now look, I want to make one thing abundantly clear. Living on Mars would not be a barrel of laughs or anything like that. It would be an exciting adventure for people who are so inclined, people who would enjoy such a thing. An adventure unlike anything else that mankind has ever embarked on, especially if you're talking about spending the rest of your life there. It would certainly be that, with so many unique and astonishing experiences that could only be had on the red planet as I described in the video. So many amazing things, but at the same time, so many things that you would have to give up, right? You'd never see an ocean again, at least not in person. You could take a swim. As I said in the video, there's a lot of water. Swimming pools, at least within a habitat, a large habitat, would not be an impossibility. And there's abundant salts on Mars too, so even saltwater pools are theoretically possible, once the settlements got large enough to accommodate such things. But at the same time, it would be extremely difficult and extremely dangerous. No doubt lives will be lost. Our species is innovative, we are intelligent, and we have overcome difficult challenges in the past, and we can overcome this. The only thing that concerns me are the second, third generations of Martians. Children who are born there, who grow up in 1/3 gravity and can never go to Earth as a result. Short of us developing some sort of technology that allows them to, they may find themselves banned forever from Earth, and that could be a harsh thing for a kid to grow up with that knowledge. That's one thing that does concern me. But then they have the rest of the solar system to pick from, because all the rest of the moons of the gas giants, none of them have the same gravity problems that Earth does. So there's a lot of adventure for Martian children in the future. So I tend to think that they're going to enjoy being Martian and be proud of being Martian rather than resentful of it. If you like what I talk about, if you like the sort of content that I put out, it's all in the description, many ways to support me. I have future trips planned and certainly could use your support with them. But as I say, times are tough, in the aftermath of the pandemic. I hope that it's nearly over, and a like and a subscribe would be greatly appreciated. So until people are living on Mars, people are enjoying the experience and dismiss these notions that colonizing Mars is impossible or impractical or would be a living hell, until we reveal these things to be the lies that they are, I urge all of you to stay angry about space.